A single-page application, also known as single-page interface, is a web application or website that fits on a single web page with the goal of providing a more fluid user experience akin to a desktop application. In a SPA, either all necessary code HTML, JavaScript, and CSS is retrieved with a single page load, or the appropriate resources are dynamically loaded and added to the page as necessary, usually in response to user actions. The page does not reload at any point in the process, nor does control transfer to another page, although modern web technologies can provide the perception and navigability of separate logical pages in the application. Interaction with the single-page application often involves dynamic communication with the web server behind the scenes. The term single-page application was coined by Steve Yen in 2005, though the concept was discussed at least as early as 2003, and Stuart Morris wrote the self-contained website at http://stateless.com with the same goals and functions in 2002. Modern browsers that can parse HTML5 allow developers to shift the UI and application logic from web servers to the client. Mature open-source libraries support building of SPA without digging too deep into JavaScript trenches and fighting with technology problems. There are few distinct characteristics of the professional single-page application. Chunking the web page is constructed by loading chunks of HTML fragments and JSON data instead of receiving full HTML from a web server on every request. Controllers are JavaScript code that handles complex DOM and data manipulations. Application logic and Ajax calls is replaced by controllers that separate views and models using MVC or MVVM patterns. Templating coding of UI and DOM manipulations are replaced by declarative binding of data to HTML templates. Routing selection of views and navigation that preserves page state, elements and data. Real-time communication two-way communication of a client application and web server replaces one-way requests from a browser. Local storage capabilities of storing data on a browser for performance and offline access replace cookies and intensive data loads from web server. Technical approaches. There are various techniques available that enable the browser to retain a single page even when the application requires server communication. JavaScript frameworks. Web browser JavaScript frameworks, such as AngularJS, UI App Framework and React have adopted SPA principles. AngularJS is a fully client-side library. AngularJS's templating is based on bidirectional data binding. Data binding is an automatic way of updating the view whenever the model changes, as well as updating the model whenever the view changes. The HTML template is compiled in the browser. The compilation step creates pure HTML, upon which the browser re-renders into the live view. The step is repeated for subsequent page views. In traditional server-side HTML programming, concepts such as controller and model interact within a server process to produce new HTML views. In the AngularJS framework, the controller and model state are maintained within the client browser. Therefore, new pages are generated without any interaction with a server. The UI App Framework is a roll-up of the app, model list, router, and view components, combined to form a simple MVC-style framework for writing single-page JavaScript applications. You can use these components separately or together to create anything from simple non-interactive views to rich applications with URL-based routing, data binding, and full client-server synchronization. Ajax. The most prominent technique currently being used is Ajax. Predominantly using the XML HTTP request object from JavaScript, other Ajax approaches include using a frame or script HTML elements. Popular libraries like jQuery, that normalize Ajax behavior across browsers from different manufacturers, have further popularized the Ajax technique. WebSockets are a part of HTML5 spec and is used for single-page apps. Browser plugins. Asynchronous calls to the server may also be achieved using browser plugin technologies such as Silverlight, Flash, or JavaPlets. Data transport. Requests to the server typically result in either raw data, or new HTML being returned. In the case where HTML is returned by the server, JavaScript on the client updates a partial area of the DOM. When raw data is returned, often a client-side JavaScript XML/process is used to translate the raw data into HTML, which is then used to update a partial area of the DOM. Server architecture. Thin server architecture, ASPA moves logic from the server to the client. This results in the role of the web server evolving into a pure data API or web service. This architectural shift has, in some circles, been coined thin server architecture to highlight that complexity has been moved from the server to the client, with the argument that this ultimately reduces overall complexity of the system. Thick stateful server architecture. The server keeps the necessary state in memory of the client state of the page. In this way, when any request hits the server sends the appropriate HTML and/or JavaScript with the concrete changes to bring the client to the new desired state. At the same time, the state in server is updated. Most of the logic is executed on the server, and HTML is usually also rendered on the server. In some ways, the server simulates a web browser, receiving events and performing delta changes in server state which are automatically propagated to client. This approach needs more server memory and server processing, but the advantage is a simplified development model because A, the application is usually fully coded in the server, and B, data and UI state in the server are shared in the same memory space with no need for custom client-server communication bridges. Thick stateless server architecture is a variant of the stateful server approach. In this case, the client page sends data representing its current state to the server, usually through Ajax requests. Using this data, the server is able to reconstruct the client state of the part of the page which needs to be modified and can generate the necessary data or code, for instance as JSON or JavaScript, which is returned to the client to bring it to a new state, usually modifying the page DOM tree according to the client action which motivated the request. This approach requires that more data be sent to the server and may require more computational resources per request to reconstruct partially or fully the client page state in the server. At the same time, this approach is more easily scalable because there is no per-client page data kept in the server and therefore Ajax requests can be dispatched to different server nodes with no need for session data sharing or server affinity. Running locally, some SPAs may be executed from a local file using the file URI scheme. This gives users the ability to download a SPA from a server and run the file from a local storage device, without depending on server connectivity. If such an SPA wants to store and update data, it must use browser-based web storage. These applications benefit from advances available with HTML5. Challenges with the SPA model. Because the SPA is an evolution away from the stateless page redraw model that browsers were originally designed for, some new challenges have emerged. Each of these problems has an effective solution with client-side JavaScript libraries addressing various issues. Server-side web frameworks that specialize in the SPA model. The evolution of browsers and the HTML5 specification aimed at the SPA model. Search engine optimization. Because of the lack of JavaScript execution on crawlers of all popular web search engines, SEO has historically presented a problem for public-facing websites wishing to adopt the SPA model. Google currently crawls URLs containing hash fragments starting with. This allows the use of hash fragments within the single URL of an SPA. Special behavior must be implemented by the SPA site to allow extraction of relevant metadata by the search engine's crawler. For search engines that do not support this URL hash scheme, the hashed URLs of the SPA remain invisible. Alternatively, applications may render the first page load on the server and subsequent page updates on the client. This is traditionally difficult, because the rendering code might need to be written in a different language or framework on the server and in the client. Using logic-less templates, cross-compiling from one language to another, or using the same language on the server and the client may help to increase the amount of code that can be shared. Because SEO compatibility is not trivial in SPAs, It's worth noting that SPAs are commonly not used in a context where search engine indexing is either a requirement or desirable. Use cases include applications that surface private data hidden behind an authentication system. In the cases where these applications are consumer products, often a classic page redraw model is used for the application's landing page and marketing site, which provides enough metadata for the application to appear as a hit in a search engine query. Blogs, support forums, and other traditional page redraw artifacts often sit around the SPA that can seed search engines with relevant terms. Another approach used by server-centric web frameworks like the Java-based ItsNat is to render any hypertext in server using the same language and templating technology. In this approach, the server knows with precision the DOM state in client. Any big or small page update required is performed generating in server, and transported by Ajax, the exact JavaScript code to bring the client page to the new state executing DOM methods. Developers can decide which page states must be crawlable by web spiders for SEO and be able to generate the required state in load time generating plain HTML instead of JavaScript. In case of ItsNat framework, this is automatic because ItsNat keeps the client DOM tree in server as a Java W3C DOM tree. Rendering of this DOM tree in server generates plain HTML in load time and JavaScript DOM actions for Ajax requests. This duality is very important for SEO because developers can build with the same Java code and pure HTML-based templating the desired DOM state in server. On page load time, conventional HTML is generated by ItsNat, making this DOM state SEO compatible. As of version 1.3, ItsNat provides a new stateless mode. Client DOM is not kept in server because in stateless mode client DOM state is partially or fully reconstructed in server when processing any Ajax request based on required data sent by client informing of the current DOM state. The stateless mode may be also SEO compatible because SEO compatibility happens in load time of the initial page not affected by stateful or stateless modes. Client-server code partitioning. One way to increase the amount of code that can be shared between servers and clients is to use a logic-less template language like Mustache or Handlebars. Such templates can be rendered from different host languages, such as Ruby on the server and JavaScript in the client. However, merely sharing templates typically requires duplication of business logic used to choose the correct templates and populate them with data. Rendering from templates may have negative performance effects when only updating a small portion of the page such as the value of a text input within a large template. Replacing an entire template might also disturb a user's selection or cursor position, where updating only the changed value might not. To avoid these problems, applications can use UI data bindings or granular DOM manipulation to only update the appropriate parts of the page instead of re-rendering entire templates. Browser history, with an SPA being, by definition, a single page, the model breaks the browsers designed for page history navigation using the forward-back buttons. This presents a usability impediment when a user presses the back button, expecting the previous screen state within the SPA, but instead the application's single page unloads and the previous page in the browser's history is presented. The traditional solution for SPAs has been to change the browser URL's hash fragment identifier in accord with the current screen state. This can be achieved with JavaScript, and causes URL history events to be built up within the browser. As long as the SPA is capable of resurrecting the same screen state from information contained within the URL hash, the expected back button behavior is retained. To further address this issue, the HTML5 specification has introduced push state and replace state, providing programmatic access to the actual URL in browser history. Page lifecycle. An SPA is fully loaded in the initial page load and then page regions are replaced or updated with new page fragments loaded from the server on demand. To avoid excessive downloading of unused features, an SPA will often progressively download more features as they become required, either small fragments of the page, or complete screen modules. In this way, an analogy exists between states in an SPA and pages in a traditional website. Because state navigation in the same page is analogous to page navigation, In theory, any page-based website could be converted to single-page, replacing in the same page only the changed parts result of comparing consecutive pages in a non-SPA. The SPA approach on the web is similar to the single document interface presentation technique popular in native desktop applications. References: A.B. Flanagan, David, JavaScript, The Definitive Guide, 5th ed., O'Reilly, Sebastopol, California, 2006, pages 497, Inner Browsing, Extending Web Browsing, The Navigation Paradigm. Retrieved February 3, 2011, /stat/.com, a self-contained website using DHTML. Retrieved July 6, 2012, http, urlibrary.com/docs, Thin Server Architecture Working Group. Retrieved December 11, 2011, The Single Page Interface Manifesto. Retrieved November 12, 2010, Darby. Retrieved December 11, 2011, Sales.js. Retrieved February 20, 2013, Ncombo. Retrieved January 31, 2013, Tutorial, Single Page Interface Website with its NAT. Retrieved January 13, 2011, HTML5, Michael Mikoski. How to Optimize Single-Page Sites for Search Engines. Retrieved January 6, 2014. When Google and other search engines index websites, they don't unregistered trademark T execute JavaScript what the user sees, what the crawler sees. Retrieved January 6, 2014. The browser can execute JavaScript and produce content on the fly, the crawler cannot, making Ajax applications crawlable. Retrieved January 6, 2014. Historically, Ajax applications have been difficult for search engines to process because Ajax content is produced, making Ajax applications crawlable. Retrieved January 13, 2011, its NAT v1.3 release notes. Retrieved June 9, 2013, external links, migrating multi-page web applications to single-page Ajax interfaces, http arxiv.org/cs/0610094, The Single Page Interface Manifesto, Google's AngularJS, Facebook's React.